Hey everybody, how's it going? So today we're going to be working on yet another dead MacBook. We have got an A1398 here that's not powering on. We're going to see how much power it's taken after we unplug the battery, see if we can make it work again. And let's see if we can get this to be a happy little MacBook. Read something interesting today while on the way to work about on Bloomberg about Amazon employees in Alabama looking to unionize. And apparently, yeah, I think that they're getting tired of having to piss into bottles to hit their workflow targets. And they are voting. And Amazon is contesting this because they're asking to vote via mail due to the pandemic in Alabama and the high testing positivity rate. And it's funny, Amazon is saying that they don't want the vote to occur via mail-in ballot because they think that it will be laden with fraud, which I think is kind of funny. I think that's kind of funny. That's how you know they think they're going to lose. So I think that I think they know that their employees are going to wind up voting to unionize in Alabama. We'll see how this winds up working out. It would be funny if Jeff Bezos comes out at the end of it when their employees in the Alabama warehouse vote to join the union, and he goes, "It's a rigged election. Mail-in ballots are full of fraud." That would be funny. All right, so as you guys saw, I was taking 12 milliamps and it wasn't giving me a green light. So I'm just going to unplug everything and take the board out, and we're going to see what happens there. So we're going to plug in the charger and see if... And we get a green light, where I was not getting a green light before. Interesting. But it doesn't really make much of a difference because we're still stuck at 17 amps, which means this is not going to turn on. Now, the first thing that makes me sad, just taking a look at the board, as you can see, is that there's no real corrosion on this. There's nothing that really... sticks out, I would say, as something that's going to be a problem. So obviously, now that I have the light back, I know that PP342 would be there, but I'm a little curious just because it wasn't there before. I'm not really very trusting, so I'm going to measure it, and I see 3.42 volts. 3.42? You're not going up and down, are you? Okay, 3.42 volts. All right, that's there. Next up, PP-Bus G3 hot. Is PP-Bus G3 hot on this board? Or is it PP-Bus G3 hot or PP-Bus G3 not? Okay, so we have 1 volt on PP-Bus G3 hot. Well, there we go. That's a problem. So the first thing I'm going to do here is I'm just going to see if there's a short on PP-Bus G3 hot. And there's not, 71 kiloohms. Now this tells me, if I were to use my psychic powers here, I think it sounds like R7121 and R7122 have a hole in them. Let's see if I'm correct. For any of you who are wondering how you could have this type of knowledge, you should check out wiki2.rossmangroup.com. 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 It's legally free for all to see. Okay. Let's take a look. Let's see if those two resistors that I thought were dead are dead. Is the path broken? No, it's not. Okay, I was wrong. I thought it was a current sensing issue. And is not. For those of you who are curious, I am not troubleshooting with Flex Board View open. I've realized that doing these board repair videos has bored the shit out of me. I am, at this point, I did them in 2014, 15, 16, 17, 18, 19, and some in 20. So that's like 7 years of the same content. I'm bored of that. I don't want to keep doing the same shit. So I'm kind of just doing board repairs the way I would if I was not trying to show and instruct people of things. So what I'm doing now is if I want to create content for people to learn from, that's what the old videos are for, but that's also what the wiki is for. Now it's just me going through my process as I do. Charger DC in is 17 volts. All right. But the Mosfet is not actually fully opening, so this is an interesting one. Why is that happening? Why Mosfet not opening? Huh? It's like it wants to, but it keeps switching itself on and off. So at this point, I have 1 volt. So it's not even PV bus is 1 volt. It's that what's coming in through Q7180 is 1 volt, and that's up here. Now, the problem that I have, and what pisses me off about this particular board, is that Q7180 is not going to be the same Q7180 that it is on other boards. They used a different chip for it on this model. And okay, well, you guys can see what happened here. So let's go over this. So on this schematic, so this is PPDC and G3 hot. This is the 18 volts coming in from the adapter. I'm just going to full screen this for a moment so that you can see it. And let's open up just the schematic by itself. Okay, so on just the schematic by itself, this is the 18 volts coming in from the adapter. And this transistor is going to be it's kind of like a light switch. It's going to be what allows that 18 volts to go through the rest of the computer. That's also going to keep the battery, technically, from being able to, quote, charge the charger. The battery is not going to be able to output its 12 volts backwards through the system via this transistor. So this keeps the battery. Have you ever bought a really cheap and shitty flashlight 18650 charger, like the cheapest garbage that you can, and you plug it in and it charges your battery, then you unplug the charger from the wall and the light is still on the charger because the battery is now charging the charger? That's how you know you bought a really cheap piece of shit that doesn't have an inrush limiter or a diode or something. And that's what they have here. So let's switch back to the schematic again and show you this. So we have 18 volts over here, but we have 1 volt over here. Now what I did is I searched for Q7180 because I'm just kind of curious. If I have 18 volts here and 1 here, either this transistor is not being told to open by the U7100 or this transistor is bad. Now the one thing that's difficult here is that this board uses a dual you see how this is 2 transistors inside 1 transistor? This board uses a different design. It uses 2 discrete transistors. I don't have a schematic for this board. I have the A20-00426. It's 99% the same as the A20-00163, which is on the screen. So I looked in that area, and this is a similar area. Now again, I don't know exactly what these transistors are. Without reverse tracing everything, I don't know exactly what these are for. I can't know that. But when you look at it, and it has this kind of shade of smoke above it, which maybe you can see a little easier if I turn the light down. So I just turn the light down. As you can see this? Oh my, okay. Well, see, that kind of makes it easy. So at this point, I don't really need to do a lot of measuring to tell, is it the ISL 6259, or is it the inrush limiter that's bad? Oh man, yeah, look at that. Damn, this thing is fading away like the bank account of Citron Research. Oh my God, look at this. Look at this. Dear God. Oh, jeez. Okay, so what we're going to do is, firstly, I want to kind of get an idea of why this happened. So I'm going to, is there anything in the area that's shorted to ground that shouldn't be? We already acknowledged that PP buses, oh my, gee, what the? All right, at this point, we're going to call on the big guns. So I'm going to be replacing myself with Paul, and yeah, Paul can have fun with this. So I'm going to find him, and yeah, we're going to trade places. Be right back.
From 12 layers of the board, didn't it? It's the only reason you would be over here, because it has 12-layer hole underneath it.
That's not the only reason. I come over to talk to you. I ask how your day is going.
No,
How's the turtle?
No, not when you're streaming. When you come over here and say, I have an easy board for you. No. Did you already heat this?
No, I haven't turned on my hot air station yet. Here you go. He's not taking the microphone because he hasn't agreed to it yet. It's not even moving.
No, nothing's moving yet.
How does this happen?
Okay, yeah, that should be moving now. Well, yeah, there's no saving that trace. Wait, I want to see something. Okay, the board is not conductive. The board's not burning enough to be conductive. Yeah, this could be saved. you're gonna have to rebuild the trace completely, but
Which trace?
this whole thing, this is not gonna come off of here. You have to just rip this off, just cut it off right here and
And put a
rebuild
wire
the
under
frame.
it?
Yeah.
Alright. Now, the thing is, do we have any 00426 donors? Because that's not the same Q7180.
Just make sure you clean up this real good, though.
Which?
Scrub off all of the carbon off of here, just in case any of it is conductive.
Do you have a 00426? Okay, so what are we doing here? So Paul approves attempting to repair it. So what do I got to do? So this transistor is supposed to be... Let's see. Now remember, I don't have a schematic and a board view for this board. If anybody has a schematic and a board view for an 820-00426, please do keep in mind that it would be incredibly immoral to email that schematic to lewis@rossmangroup.com. You should not do that. That's not the right thing to do. It's not what Tim Cook would want you to do. It's a bad thing. So if anybody has a genuine schematic for an 820-00426, you should not, under any circumstances, allow me to have access to that schematic by sending it to me. That being said, now I don't know what that metal thing is under there. That could be ground or something, so I'm going to green over to that before I put my wire there. Alex, stop. Alex, you don't make me laugh. Okay, that is indeed ground under there. So there's ground under this. So what I need to do is I need to make sure that this is covered up good. This has to be covered up, and this needs to be UV'd. There is shit under here. There is some shitron research under there. Okay. Okay, now I need my UV pen, which is also available on store.rossmangroup.com. By the way, none of you people should be looking at the screen right now because UV is bad for your eyes. So if you're looking at the screen right now, you could be looking at UV light, which is bad for your eyes without any sort of protection. So do not look at the screen right now. This is bad for your eyes. Very, very bad. It will actually... You could be damaging your vision by looking at the monitor right now. Do not damage your vision by looking at the monitor. Do not damage your vision by looking at the monitor without UV goggles. Because when we do this here, since we're professionals, UV goggles or glasses. I'm unsubscribing. Lewis did not read my comment and burned my eyes with UV. Oh, thank you. This is getting... Thank you, I appreciate that. Okay. I got some on the two resistors next to it, but honestly, it doesn't really matter here. Now remember, that's supposed to be going to the chip right next to it, right? This transistor is leading... That trace is leading here. You gotta flatten that out. Okay. I really could use a kind of a, not a wire necessarily, but kind of like a baking sheet. Something that's shaped like a baking sheet would actually be really nice here. Because I want to solder, I want the transistor to get soldered to that. So the transistor that I put here, it needs to get soldered to these 4 pads on the right side, but it simultaneously needs to be soldered to that sheet. So I got some wire here. Can use a thick pad from another board instead. I would have to rip the pad off. I would have to rip everything off, and that would be kind of a... The amount of work involved to do that, for it to be not considerably neater than it would be this way, I don't think would be worth it. All right. So this here, I believe, is 34 gauge. And this usually would, if this would not be acceptable if it was a long distance, but this is pretty much being used as a trace. So I think it's okay. This is not going a long distance. I'm actually going to make a little box out of it. So watch. Check this out. This is going to be a little box. So we're having 2 tweezers comes in handy. Watch this. See this? All right. So check me out. All right, so I made myself a makeshift pad, makeshift trace. Maybe I'll go across with it just to be... Nah, that's gonna be too high. This is fine. All right, now we just rip off the wire. That's the whole point. We don't want it to be insulated. That's the whole point, is to remove the insulation from the wire. Because if it's insulated, then what's the point? I mean, I'm not going to be soldering it to anything. All right, get some flux in there. And away we go. Shit. This may actually be more difficult to do it this way. All right, there we go. Okay, let's see what we get now. Turn on or fire, turn on or fire. 1 amp. And the fan is spinning. Now, the one problem that we're going to have here is that that chip is no longer heat sinked. It doesn't have a ground pad anymore. So I am concerned about... It's not going to be grounded to the... It's not attached to the board anymore. Because on the other... it's not even like I could just grab that from the other board, because I would then have to find a way to attach that to the inside of the board itself. So I'm kind of curious, if I leave this on for a little bit, is it going to start boiling? Just clean this area a little bit, and I'll feel that Mosfet in a minute and see how it feels. See if it's being heat sinked. Yeah, that feels all right to me. But then again, I don't know how it's going to feel, an hour from now, or especially after a charging session. So I'll probably put this thing through a charging session and check the temperature of the chip after it's been on for a bit. Because you have to keep in mind, right now it's using 1.4 amps. When it's charging the batteries, you're going to use 3 or 4 amps. So we're going to see if this burns at 3 or 4 amps. And if it doesn't, then that means that we have a fix. I'll just, ultrasonic the board, put a little bit more green stuff on that area, clean it up a little bit, and that'll be that. So that's it for today. And as always, I hope you learned something. I'll see you all in the next video. Bye now. And as always, if you want this information, check out wiki2.rossmangroup.com, where we have many detailed guides on how to fix boards. Again, I don't post as many board repair videos anymore. I have been doing board repair videos on this channel for 7 years, and at this point, I just kind of find them a bit same old, same old. There's other things for me to do in business and in life, and I'm focusing on them. And I don't know. This channel kind of used to be like just the Louis Rossmann variety show of me recording whatever the hell I was doing at the time, and I'm not doing as much board repair. So it's business management and everything else I gotta do and deal with, and that stuff's just not particularly exciting for video. So I'll see you all later, but don't want to give up on the educational stuff, so I'm just changing the format is all. It's just not a video anymore. It's all on wiki2.rossmangroup.com.